Hello everyone, welcome to another video of my channel. Today I'll be talking on a new problem named binary tree level order traversal. Its LeetCode number is 102 and it's a medium categorized problem. So let's get started. Let's have a look at the problem at first. The problem says, given the root of a binary tree, return the level order traversal of its nodes values. That means from left to right, level by level. So here you can see a binary tree, and as we can see, this binary tree has three levels. This is one, this is the second one, and this is the last one. So we will have to show for the first level, at first we'll show 1, then for the second level we'll be showing this 2 and 3, and at last we'll be showing 4, 5, 6 and 7. So you can assume each of these levels elements as a single array. That means this one, this is an array, this 2, 3, this is another array, and 4, 5, 6, 7, this is another array, and the final output will be an array of array. So now let's start to solve this problem. Seeing the problem statement, the first thing that should come to your mind is solving this problem using BFS or breadth first search, because this breadth first search traverse a tree or graph by how it traverses at first the root, then all the descendants of that node, after that the descendants of those nodes in a serial wise. So our solution approach will be inserting the root to the queue. That means if you do not know, we use a data structure called queue, which is first in first out, in order to solve DFS related problem. So here we will also be using a queue. Then at first we inserted the root to the queue. Now we will have to run a loop. This loop will indicate until our queue is empty, we will run this loop. Now before popping something or before popping any element from the queue, we will have to take another loop. That is, we will take the size of the current queue at that moment, because we need to identify all the nodes at the same level together. If we do not take the size of the queue and run another loop, we cannot distinguish nodes of a particular level. That's why we just take the size of the queue and we run another loop. That means we take the size of the queue to a variable, and until the variable is 0, we will do our task. Which tasks we'll be doing? At first we will pop the node from the queue, and then we will add its left and right child. If they are not null, we'll be adding the left and right child to the queue, and the node we popped, we will be appending the node to our output, say an array or list, and we will be repeating it once this our variable, that means the size of the current queue, is not 0. Once this is 0, then we will be appending this list to our final output list, and this will go on until the queue is not empty finally. Thus we will be solving this problem. As you can see, at first we have pushed the root to the queue, and this is our outer loop while the queue is not empty, and in every time we took the size of the queue before popping anything, and this is our inner loop. So let's try to submit this problem and see what we get. So we got accepted, and if we want to discuss about the time complexities, since this approach covers all the nodes once, so this will run big O of n, and as we are using a data structure, external data structure Q, that will contain at most n numbers of elements, so the space complexity will also be big O of n. I hope you guys have understood the problem and its solution approach. Thank you very much.